So welcome to the new series on hardware and electronics. And in this first episode, we're going to learn how to solder. It's a very useful and important skill and technique to have to be able to join wires together and to solder things. So we're going to take a look at various different soldering irons, from the cheap to the mid-range to the very expensive. We're going to try different solders, all of ones which I own. And then we're going to try and solder together wires, circuit boards, resistors, and go through the techniques and skills involved. So let's get to it. So the first thing we need to do is choose an iron so that we can do some soldering. So we've got three in front of us, and let's talk through them. So this first one is the lower end. It's the cheaper model. It's £12–13. This middle range one is about £70, and the high end one here is about £600–700. So obviously this will depend on your budget and what you need. So the benefit of the cheaper iron is obviously it comes with a stand, it comes with a pump, wire, tweezers, all the bits you need to get going straight away. It even comes with solder. So you could buy this kit and solder straight away. The downside is simply really the warm-up time of the iron, I'd say. It takes longer to get to temperature. It can't regulate temperature as well, which when you get to more advanced soldering, like soldering outdoors, soldering big joints, those things will become important. But initially, for most people's general DIY soldering, this is more than enough. There's no need to go any further. Then we step up to the mid-range one. As I mentioned, this is about £70. It's called the TS80. It's very popular. Sorry, the TS100. The successor coming out soon is called TS80, which, if it's out when this video comes out, I'd also recommend. But this is I believe, a Chinese model, but it's actually a really good model. It comes up to temperature really fast. It's powered by a simple DC plug, so it's on the go, nice and easy. It also means you can battery power it from a 12-volt power supply or a 20-volt power supply. The common battery phone chargers, the little power banks. It's also smaller than the other iron, so it's nice and compact and easy to use. And then we have the top end one, if you will, the Wyler. Comes with dual sockets so that you can have two irons at the same time at two different temperatures. More industrial grade for people that solder a lot. It's very light. I think it's made of aluminium, some kind of light material. The tip's very fine, but that doesn't actually matter too much. But the main benefit of this is it's really light, easy to handle, and gets up to temperature and regulates the temperature the best out of all of them. But obviously the downside is the extreme cost in comparison. So my personal preference would be probably 90% of everybody watching will simply start with this kit, and this will do you for majority of what you ever need to do. But if you've got the money, I wouldn't even recommend going to Wyler unless you really are in the industry and you just want the best of the best. I would recommend going to the TS100 if you can afford, and after you've tried the basic soldering iron first, because there's no need to pay more when the lower iron can do everything you need. So we're going to start with this iron. We're going to take a look at how it performs, how quick it warms up, how good it is at soldering. So I've got the first iron here. I've got the temperature set to 300 degrees Celsius, which is what I tend to start the soldering at. So I'm just going to plug this in and measure how long it takes to warm up. So it's on now, so we'll start the timer, and now we will basically take the iron and just start touching the solder. And we'll just keep waiting to see how long it takes to warm up. Now, with this being one of the budget irons and it being this style of heating element, this will likely take a while. So we'll just keep watching and see how long this takes. I'd expect usually on an iron of this cost take a few minutes. So let's just keep going and see, and let's wait for it to start melting. So there you can see it's just about starting melt. So about 50 seconds, that wasn't too bad. And now you see all this smoke coming off the tip. This is not the solder as such, this is the flux inside the solder. So this smoke you don't want to be inhaling. It's not good for your health. So you can read the data sheets on the flux. We will in a future video build a fume extractor to suck away these fumes, but in general, if you're starting out, just try not to breathe the fumes in, basically. But I do recommend getting a fume extractor. So that's that one. That took about 50 seconds to melt. So next we are going to do a temperature regulation test. And for this, I've just got a big thick piece of copper, a copper plane, and I'm just going to touch the iron on, feed a bit of solder in, and we're just going to kind of more visually see what we feel of how well it's going to maintain the solder. And I can feel it's a little bit hard. It's not, I mean, that solder there is still hard. And this is the difference between the cheaper irons and the expensive ones. When you're trying to solder a big patch or like a large heatsink like this, the solder is really struggling here. So the option you have there is to simply crank the temperature up and say, whack the temperature up of the iron, which will then take a little while to warm up. But I'm just getting a feel for this. And like I say, it's harder for you to see, but you should be able to see this isn't very fluid. This is still hard, and you'll notice the difference with the other irons. So this is the difference I'm mentioning between a cheaper iron and a more expensive one. The ability to sink a lot of heat. So now the iron's warming up to the hotter temperature. I set the iron to about 400. This is now starting to get more fluid and more capable. So now that's got it. So again, the iron is still capable. I've just had to up the temperature and give it a little time to warm up. And now we've got a fluid patch of solder. So that's the test for this iron. So now it's time to compare the TS100. So let's see how this performs in comparison to the cheaper iron. So this is now the TS100. We've got it connected. So you can see on this now we get a nice little display, and it's telling us to press this button to turn it on. So let's measure the warm up of this, and this iron should be a lot faster. So as I press A, I'm going to press the start. So here we go. And there you go, you can see already the temperature's rising. 80, 90, 100, it rises really quickly. And 200, and then it's starting to melt. So you're talking probably 12 seconds there, and that's already up to temperature. So that didn't take long at all. So now we'll go on to the temperature regulation test. So we'll get the same piece of copper that we did before. And this time, remember the last iron we had to up to 400 degrees. This is still at 300. So let's just touch on here, just near it, and feed some solder in, and just get a feel for how it maintains. So there, we've started a puddle now. And as I feed it in, it's still struggling a little bit in terms of staying wet, if you will. It starts getting a little bit hard. But overall, this is expanding quite well. It could probably do with a temperature boost, but again, this is actually maintaining a puddle. So the other one wouldn't even maintain a puddle. So if we just increase the temperature to 400 to match the other iron, you'll also see how quickly, let's go to 390, I don't think we need to go to 400. You'll see how quickly this rises. Once it's off, now it starts rising up. So it's a few seconds. Now if we touch on, we should hopefully get a lot more fluidity. So there we go, it's now picked up temperature, and now we can see we can maintain that puddle. So overall though, I wouldn't say the difference in that was massive in terms of the large puddle heatsink. It's still fairly difficult to do, but it did maintain better than the cheaper iron. So last up, let's test the Wyler iron, the most expensive of all three, and let's see the comparison and how well this performs. So finally, we've got the top spec Wyler soldering iron. So this one's got its temperature on the power supply. So I'm just going to bring that into view so you can see on camera. Let me just lift up the view as well so it's in clear sight. Now this one obviously warms up very quick. So this is going to be probably warmed up before you even get to grab the solder. But here we go. So I'll start the timer and I'll turn the plug. And then I'll try and pick up quickly. And it's already up to, there we go, melting. So you can see on here the temperature, how quick it gets up to temperature. I don't know, that was maybe 2 seconds. That's how quick this iron is. And that's actually got to 380, not 300. So that's literally how quick this iron can get up to temperature. You can lower the temperature down to 300 for a fair test on the others. But again, to get up to 300 degrees, it will take literally 1 to 2 seconds. So obviously this has got a super fast warm-up time, which is beneficial when you're busy and you just want to solder. So that's that. Let's move on to the temperature control test. So let's just place this down and we'll do the same test again over here. This time we're at 300 like we started with before. And this one's handling it, I'd say better, because we're still on 300. It's again, could probably do with a bit more heat, similar to the last one. But it is handling it. It's managing to pump out the heat, and to be honest, we might not need to go up to the 400 on this. I'm getting a little bit of grittiness, which means it's not quite fluid. So I'd say similar again. We'll just crank the temperature up. I'll just chuck this up to the same as before, 390. We're on 385, but that's close enough. And also I've got a really small tip on this iron, so that's slightly against it, but not too much. And then again, there we go, it's fluid now. So I'd say very similar results to the TS100, although the warm-up time is insanely faster. And I'd say this temperature regulation is slightly better, but certainly no means it's 10 times better, considering the cost difference. So based on the test of all three there, the iron I'm going to recommend for the rest of this video, and to start with, is I think just going to be the basic iron. It still handled making a puddle, it still handled all the tests, took a little bit longer, but overall this is £12 compared to 700. So let's carry on and do the rest of it with this iron, I think. So now we've seen how the irons perform, let's take a quick look at the solder and the differences between solders. So I've got a variety on the table here. I've got a lot of lead-free solders and a few leaded solders. They all come with different things inside them. You've got tin, silver, copper, nickel. You get all varieties of different elements in them. To me, they make very little difference. The main difference between all solders is simply whether they've got lead in or not. My personal preference is I use leaded solder for one main reason: it's easier to work with. So it melts at a lower temperature, it stays fluid for longer. It's just generally easier to work with. It's not the industry standard now due to it being leaded, but as a hobbyist and as using it for yourself, I'd personally recommend the leaded solder. So let's show a quick example between, say, this lead-free solder and this leaded solder, which is my favorite here. And I'll show you the differences, what I mean, and how it's harder to work with. So I'm going to try to demonstrate the difference between leaded solder and lead-free. And the only real difference I find is the ability to work with it for longer and the ease of it melting and staying fluid for longer. So we'll be doing wire joints and surface mount joints shortly. But in order to kind of show the solder, we really need to actually do a joint. So I'm going to start with the square pad and do it with leaded solder. So if I just touch on and melt the joint, and you can see you've got a nice joint there, a nice flow. And if we go back and warm it up and come off again, you see it's still nice and pyramid shaped, if you will. And you can keep going back and forward for a good while. And eventually, if we just leave on this, you'll find that the solder will start sticking to the iron and not the joint once all the flux is burnt out. So as we start doing this, should eventually, as the flux gets burnt up, stick to the iron and not the leg. And you can see with this, it's lasting, a very long while. So I'm trying to purposely get it to actually stick to the iron and become dry. But this is, like I say, my best leaded solder. This is what I found works the best. So we may not get this actually drying up. So there we go, we're starting to dry finally. Now you can see how it's going sort of not wanting to flow back down and very sort of dry in the joint. But you've seen how long we've worked this for and how long it's lasting. So there you go, it's finally sticking to the iron now. So we've had a long run of that sort of lasting. If we now go to the other joint and use the lead-free solder, and I will try and probably spin this around and just get this back into focus, which I think is about there. Now, if I do it on this one and put the leaded on, I don't know if I can get this in the right angle now. Let me switch hands. There we go. And you can see similar thing sticks on, but look already, the leaded is already sticking to the iron after practically one use. So there's a lot less working time with the leaded solder than there is with, there's a lot less working time with the lead-free solder than there is with leaded. So that's one of the reasons I prefer leaded solder, is the ease of work, the longer working time to do your joints. So hopefully that was a good demonstration, and you can kind of see, and the more you do soldering, the more you'll appreciate the benefits of actually using the leaded solder versus the lead-free. So now we've chosen our iron, we're going with the cheaper of the three, and we've chosen our solder, which is the leaded solder over here. Let's get to the most common and useful technique for soldering, and that's to join wires together. So one of the most useful things is to be able to join wires together in soldering. So we're going to take these two wires and we're just going to solder them together. So we will first just strip the wire. So I'm just going to basically grip. All I do, you can get wire strippers, but what I tend to do is simply pinch partly with the wire and then pull without clipping it in half, and I can strip the wire nicely. So same thing with this, I'll just pinch around like that and then pull and kind of strip the wire. So with the wires now trimmed, we want to join them. We'll obviously want to place them close together and then solder them. But the first thing I'd do, instead of just simply placing them together and soldering, is I'd tin each one. So if we've got that there, the way you want to solder now, because this is the most important part, is you want a little bit of solder on your tip, and then you want to touch under the wire. And the reason for the solder on the tip is to bridge the air gap between the iron and the thing you're trying to warm up. But then you want to feed the soldering from the top, like touching the actual wire itself. And the reason for that, as we mentioned, is as soon as you put solder on your tip, the flux starts burning off. So if you're putting it on your tip and then touching, you're putting dry solder onto the wire. So you want to just put a little bit on your tip to bridge the air gap to allow heat transfer. Now you want to hold it on the wire, and you can see already it's flown on top of the wire. So it's underneath, and then just touch the wire and the solder should flow on the wire. And the quicker the better. So that's one wire tinned. So if I just move that out of the way, and we bring in the red wire, we get that there. And then we do the same again. So you can see the tip's getting a bit dark and dull. So you typically clean this off. The one thing you will notice with the cheaper irons is the tips aren't as high quality, so you have to clean them more. But again, it's a difference between price versus putting up with those things. So I'll tin the tip a little bit, touch it underneath, and apply the solder to the wire. And that's all there is to tinning the wire, and that's a good thing to practice. If you do this the other way, where you simply apply the heat and feed it in on the iron like this, you'll notice, see how we're getting the drag again, we're getting the dry. So that's what we don't want. That's why you apply from one side the heat and apply the solder the other side. And you can see the flux in the fresh solder is also helping the dry solder to reflow. So the other important thing when you're doing the soldering is that if your iron is too hot, you'll dry the solder out quicker. So right now we are at 300 degrees. So if we turn this down to say 220, and if I just cool this down, if I just bring this board in and just cool the tip down by trying to warm this up, that'll take all the excess heat away from the tip. So we are down to the 200 degrees that we want to be down to. Then we should notice if we tin wires, or we generally work now with this tip cooler, as long as the solder still melts, you'll have a bit more working time. So you don't want your tip to be too hot, because then you've got less working time. But it's all about the situation and the specific wires that you are doing at the time. So if I'm just going to bend these wires into a position that helps it stay together. And usually here you can have helping hands. So if I just position these here, you can see we get them close enough. You can then do this one-handed like that. It is obviously much easier with helping hands, but I'll just do this on my own for now. Now they're both tinned, this will be much easier. So all you want to do here really is put a little bit of solder on your tip and go between the two wires. Try to bridge the ball of solder that's on your iron between the wires to get them to join. So if I just put a ball on the tip of my iron and go between the two, you can see they flow together, and now they've joined together nicely. And then if you want to try and align them better, obviously you can hold one wire like this and warm up the other, and get a joint. And you can keep going. Again, the longer you go though, the drier the joint will be, so you'll have less working time. But because I'm using the leaded solder, we can go for a few attempts before the solder starts getting dry. So that's one joint. That's the simplest way of joining two wires together. So now I'll show you a few more ways and a few more different wires and join them together again so you get familiar. So another way of joining two wires, say we have two wires that have been stripped, and you might want to just put them together like this. And then you can put them together, level them up, say, and just twist them around each other until you have effectively a solder-free joint. So these are now connected, not really tightly, but they are joined. They'll come apart like that. But that's an easier way, especially if you've got only yourself to do this. You can kind of twist them together like this, and then if I just get this into a good position for soldering, I want to go up a little bit. There we go. So now all we've got to do is basically apply solder to this joint. So again, the technique is exactly the same. And then what we'll do is just get the iron, get the solder, same again, a bit of blob of solder on your iron tip, apply to the wire, and then just touch the solder over the wire itself, and you can see it will melt onto the wire and join it together nicely. And you should also see then, if we were to turn this over, that the solder has gone all the way around. So it's not just gone on the top. And that's because once the wire is warm, the solder will flow naturally into all the places where the wire is warm. So that's now a solid joint, and it's all soldered. And then obviously you just have to bear in mind that your wires now, if you wanted them flat, you'd maybe have to flatten it one way, do that, and then wrap insulation tape or heat shrink around. But that's a second way of soldering wires together. I'll show you one more, and then I think we'll move on to the PCB soldering. Okay, so the last one I want to show you is a very strong knot. This is using just single-stranded wire this time, so solid core wire. And you basically put a 90-degree bend on each wire. And then you want to... Oh, I've done that too far down because we have to wrap around each other. So I'll put the bend about midway. Then what we want to do with these two is to hook them into each other. And we want to start wrapping them around each other, but not backwards. So the black one will actually wrap around the red wire, and this red one will wrap around the black. So we'll start with the black, and you want to keep the wraps as tight as you can. So we'll get this, try and get it in a good grip, and we'll start wrapping one around one way and one around the other. And you sort of want to be as tight as possible. This is not tight at all, but this is just for trying to demonstrate it on camera. It'll also be easier for you to see what's happened. So basically, you can see a really poor attempt at showing you that there. But what that is the black wire has come in, then wrapped around the red wire, and the red wire has come in and wrapped around the black wire, so that they are already quite tight together. But what you want to do is those knots want to be really tight against each other. And it's hard to show you on camera. So what I'll do is I'll bend one off camera and show you that just now, and then we'll solder it together. And so here it is when I've done it a bit more tidy. I haven't done many turns, just wanted to kind of show you the point. If any of you know the name of this knot, feel free to comment. I always forget the name of it. But the point of this knot is also to be effectively stronger than the original wire. So all we've done, the black wire's come in, bent out, and then wrapped around here. And the red wire's come in, bent out, and then wrapped around this wire. And now the last step is, one, you shouldn't really have any sharp edges poking out. So you trim them as close to flush as you can. And now you just want to apply solder to the joint, just like we did before. So I'm just going to try and bend this up into focus, and we'll then just apply some solder, just the same as we did before. So there's the join, and we just want to take our iron as normal, get the solder, And this time we'll apply a bit of solder under here, and then again over the top, just touch the wire, and it should melt onto the actual joint, and then just rub along. You should see that it basically fills in. And you can see how we've got the dry bit there from being on too long. Oop, holding the iron way too far apart. There we go, and we just rub along, and I may have excess solder there doing that, but as we spin around you can kind of see it's filled in all the grooves. It's not a very clean joint. You know, when you rub across you've got a bit of dry solder. So one thing we can do there to help that is to apply a little bit of flux, which I'll do a separate episode on in another video, but let me kind of show you what applying flux will do here. So we'll just get some of the Amtech 559 flux, which is the best flux you can get really. Put a little bit on. That's fairly excessive, but you can never have too much flux. And what that will do now is it will make the solder act like it was fresh, if you will, like you've only just applied it, so it will flow. So any of those areas where the flux was dry, or we had any of those sharp edges, you'll see now all I need to do is touch and go along, and it's all flowing nicely into joints. So that's basically the joint now done. And then finally, to finish off this episode, let's solder some through-hole components on a circuit board, which is another very common technique when you come to make your own circuit boards. So here's a little PCB. We will make these in future episodes, but for now this is just a board to solder chips to and break them out. So I'm just going to use this and get a few resistors and just poke them through the holes so they just go through, and then just go through another one, sort of push that in. Probably needs to go the next one over. And I just want to get that sort of through the holes, if you will, like that, just picking two holes. And this is called through-hole components because obviously you poke them through a hole. So that's how they go in, and then we need to solder them in place. To keep them from falling out, you typically bend the legs you know, slightly outwards, like that, to keep them in place. Some people go a bit extreme and kind of do that, so it doesn't fall out. Or you can do one leg, but that's good enough for what we want to do. And I want to kind of show soldering these on. So again, the technique's very similar. I'll just lie it flat and we'll just go for it like this. So I'll just get the iron again. And this time, same again. We want a blob of solder. Principle's always the same. Blob of solder on the iron to bridge the air gap. We want to touch this side of the leg, and then we want to feed the solder in from the other side. And what we're looking for, again, is a nice smooth sort of pyramid. So I'll show you that once we do the joint. So blob the solder on the iron, touch from this side, and feed in from that side, and then move off. And so you should see, hopefully there, a nice pyramid both sides. It's flowed to the top and to the bottom, and you've got like a nice, you know, smooth pyramid, and that's what you're looking for in a joint, is that sort of that smooth joint. And then you'll just take your clippers and snip it off at the bottom of that, and then you have a nice smooth finish. And we'll do this other leg. So the principle's the same. This time I'm going to make it dry, so I'm going to overburn it. So I could also set my iron up to much hotter than it should be to burn it out quicker. And I'll kind of show you what will happen when you basically leave it on too long. So we'll put some solder onto the iron tip, and then we'll apply some solder here. And then again, we've noticed though this is leaded solder, so this will take a while to burn off. You can see it bubbling. That's kind of the flux still burning away. And then you can see it going a little bit dull. And eventually it would stick to the iron when it gets dry. But a really bad joint would be, well, you can see we're now starting like even burn the board and things. So if you get joints that start doing this and getting dirty, then you just want to stop, turn your iron temperature down, clean it off, and start again with some fresh flux. Otherwise you end up with sort of all black residue and mess like this. So that's kind of a hint at what is happening if your solder melts but you're getting all kind of mess and things like that. Turn your iron temperature down. And I'd recommend really starting with the lowest temperature that melts the solder until you're used to soldering. And you should get joints similar to the first. And then I can also just show you filling in the holes. So if I turn the iron down, and in here we just wanted to fill the holes in. Similar again, you basically put the iron one side and kind of dab your solder to fill the holes. And you sort of just do this one after the other. And this is probably good practice to get familiar with just simply the technique of applying solder from one side and you iron the other side and you're sort of feeding in, and you can go ahead like that. Soldering works mostly with surface tension, so if you bridge something like this, what you'll find is you don't need to worry too much. If you just apply a little bit of solder, fresh solder, and blob and rub, it'll stick to the iron and you can wipe it away. But again, I'll do an episode specifically on finer solder joints, as well as how to fix bridges and solder and things like that. But like I say, it's a simple case of either apply more solder or simply apply some flux and let surface tension do the work for you. So if I just burn this joint out here, you should see a difference then between a good joint and a bad joint. So now you can see how dull that joint's gone and how it's like sticking to my iron, and it's not shiny, compared to the other joints that are a lot more, they've got a lot more sheen to them, compared to this one here that we've dried out and this one here that we made ragged. But hopefully that's been a useful little tip on soldering some through-hole components. And that's it. So I hope you've enjoyed this episode on soldering and that you can now go off and try to solder for yourself. And do let me know in the comments how you got on and if it was useful. And I'll see you in the next one. Oh, you know what? This whole video I'm out of focus. Yeah, I'm way out of focus.